Assalamualaikum and hi! This is our project of subject numerical method with the title Accurate Area Estimation of Irregular Shape. The shape that we choose is the sole of the shoe. This video was made for our lecturer Dr. Muhammad Agus Salim. Before we start with our content, let me introduce you our team. Me, Izzati Zukrina binti Muhammad Rasdi, and my friend is Adlin Nasraya binti Baharuddin.
First of all, let's see the introduction of this study. This study is done to calculate the area of the irregular shape, which is the sole of the shoes. In this study, we focus to understand and apply mathematical or computational approach to calculate the area of the irregular shape. At the below of the slide shows the picture of the shoe sole that we use in this study. Next, there are three objectives of this study. First, to determine the area of the irregular shape. Second, to implement the trapezoidal rule in finding the area under the curve. And lastly, to make us familiar with the trapezoidal rule. Now, let's move on to the methodology of the study. To complete this study, we use trapezoidal rule as our solution to find the area of the shoe sole. Trapezoidal rule is one of the numerical methods that be used to evaluate area under the curve. Trapezoidal rule is a rule to find the value of the definite integral. It is called as trapezoidal because we total the area under the curve and divide it into smaller trapezoid. A trapezoid or trapezium is defined as a quadrilateral that have two sides of parallel and two sides of non-parallel, but all four sides are closed shape. The area of trapezoid is denoted as D equal to half of sum of non-parallel side multiplied by the distance between it.
Next is implementation. We already know to calculate the area, the process involves estimating the integral and determining the area of each trapezoid formed by the curve. So, the interval that we has been identified is 1, 9. Next, we must divide the interval into subinterval. In this case, the number of the subinterval denoted as n is 8. So, n equal to 8. To compute the area, we must follow this step. First, calculate the step size h, which is h equal to b minus a over n. Before that, we already got interval ab is equal 1, 9. So, 9 minus 1 over 8, we got h equal to 1. Second, estimate the point. The value of the function at each subinterval point, denoted as y, are estimated and multiplied by the corresponding coefficient. The third step is apply the trapezoidal rule to compute the area, which is t equal to h over 2, and we can adding the coefficient that we got before. Last step is consider the irregular shape of the graph. The total area is calculated by dividing the sole into two regions, which is the upper area and the lower area. To get the final area, we must subtracting the lower area from the upper area.
This is a sketch of the shoe sole and trapezoid with the XY point on the graph paper. Now, let's look on the result and the discussion on the study. To calculate the area of the shoe sole, we divide into two parts, which is area of upper shoe sole and area of the lower shoe sole. For the area of upper shoe sole, the interval is 1 to 9. the number of subinterval n equal to 8 and we get the step size h equal to 1. The initial point and the end point of y we multiply by coefficient of 1, while the rest point we multiply by coefficient of 2. And then we total up all the value of multiplication of y and the coefficient. Lastly, we multiply that total by h over 2, which is 1 over 2. Therefore, the total area of upper Shusul is 50.45 centimeters squared.
This is the estimate point for the lower area. Same goes like the upper area, we must to calculate the lower area using the trapezoidal rule, which is we get t equal to 1 over 2, 2.5 plus 2 plus 2.4 plus 4.5 plus 6.2 plus 7.2 plus 8 plus 9.4 plus 6.5, which is we get t equal to 24.35 centimeter square. Last but not least, to find the area, the sole of the shoe is we subtracting the lower area from the upper area. And we got 50.45 minus 24.35. And the area of the sole of the shoe is 26.1 centimeter square. In conclusion, the trapezoidal rule is useful numerical technique for estimating the area under a curve, especially when working on irregular shape. Like this project, we use the sole of the shoe. The trapezoidal rule provides a reliable estimate of the integral. As the number of subinterval increase, so does the result precision, making it a flexible tool for range of application. Overall, this approach is frequently employed in numerical analysis to solve problems involving irregularly shaped graph or curve, estimate area, and calculate the integral. I think that's all from us. Thank you for listening, and Assalamualaikum.